Good evening. We're so excited that you joined us tonight. Tonight we're going to be spicing up mathematics using Python, and I can't wait to introduce our presenters for tonight. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. And joining us tonight is Becky Beyer and Adam Pennell. Becky is a nationally board-certified teacher who teaches grades 9 through 12. Her current classes at Kelly Walsh High School include AP Statistics, AP Computer Science Principles, AP Computer Science A, C++, and Python. So she's a great resource to have with us tonight. Becky, thanks so much for joining us.
It's great to be here.
And Adam has spent the last 24 years teaching at Greensboro College. He is also a TCube national instructor and loves exploring new ways to help students learn. When Adam is not teaching, he enjoys spending time with his wife and his son. He's married to Janet for a mere 30 years, and his son is 12 years old. Adam, thanks so much for joining us tonight.
Glad to be here. I'm looking forward to this.
Becky, would you mind talking through our expected outcomes?
I sure will. So we're going to start out with welcome and introductions, which we've done so far. We're going to show you how to get to the explorations with coding and demonstrate what the factor darts activity is going to look like that we're going to do tonight. We're going to show you how to get started on a TI-84 plus CE Python. And then we're going to switch over and show you how it looks on a TI-Nspire CX2. We'll work through the first half of the factor darts activity on the CX2, and then we'll finish the darts project using the 84 plus CE Python. Don't forget to stick around because at the end there is a webinar drawing and somebody is going to go away with a free calculator.
Thanks so much. And Adam, would you mind talking through our expected outcomes?
Not at all. And unexpectedly, I can actually see them. All right. First, we want you to be able to say, I can use Python to engage my students in learning how to factor quadratic equations. Basically, that's what we're going to be doing in today's project, so we think you ought to be able to do it. We think once you've done this one, there's others very similar to this on the TI website, and so we think you can do those too. We think you can do and you'll be able to say, I can to this, do your own Python project. And really the way these projects, the materials online are laid out, they're very similar to 10 minutes of code. So if you can do these, you can also enhance your Python learning with the 10-minute of code activities.
Perfect. Thanks so much, Adam. We're expecting a large crowd tonight, so your audio is muted. Feel free at any time to send any questions that you have to Becky or Adam using the Q&A window on the right side of your screen. We'll also be using that chat window to send general messages. I noticed that some people have already started putting what they feel like their experience level is with Python, so that's been kind of fun for me to read through. Looks like we have some varying levels with us tonight, which is always a good thing to have. We can help support each other. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. So, Becky, let's get things started. Feel free to share your screen.
All right, so to begin, I'm going to show everybody how to get to the activities. Tonight, feel free to try to code along, but at any point in time, if you get overwhelmed, that's okay. Stop coding along because like he said, it's going to be recorded, but then we're going to show you how to get to the activities as well. So on education.ti.com, under the activities link, there are two places to go. You could either go to the 84 Activity Central or Math Inspired, just depending on the platform that you're running. So I'm going to click on the 84 Activity Central. And then there's this link called Explorations with Coding. I'm going to click on Coding with Python. And then you'll notice that there are several activities from there to choose. Tonight, we're going to specifically take a look at the factor darts. So once you've picked an activity, if you click on it, it will give you the objectives and a little bit about the lesson. And then you'll also notice there's a download link. When you press download, you will download the student activities as well as the teacher notes. Both of them are written so that we assume that you know nothing about Python, and those of you who know a lot about Python might not need quite as many of the notes that are there. But when you open them up, I'm going to take a look real quick. This is the teacher document for the factor darts that we're going to do today. Gives you a little bit about what the problem's going to be. They tell you what the programming objectives are and what the math objectives are. And then they're going to give you an example. So tonight we're going to walk you through factor darts that will generate factoring questions. For each question that the student gets correct, they're going to earn a dart. So if they play 5 times and they get 5 questions right, they'll have 5 darts to toss at a dartboard. If they play 6 times and they only get it right twice, they'll have 1 dart. And then we will use the plot library on the 84 to plot out the dartboard and let the students toss their darts. And then we will create a scoring feature that will let us score them. As you scroll down in a teacher document, it will tell you how to start a document, and it will walk you through step by step the code that you need, and it'll even walk you through the menu options. You'll notice tonight, Adam and I are going to show you a lot of different, use this menu and you can find this. That way you don't have to type everything in. You can start typing everything in if you want. We could type the word from random import, but a lot of times there's a shortcut method by using the menus to make that so you don't have to type quite so much. So with that, here is the final product on the 84. If I tell it to run, notice I'm going to get a factor dart question. I need 2 numbers that I guess multiply to 0 and then add to 6. So let's try 0, whoops. And then let's try 6. Okay, I don't get any message down here, so that must mean I'm correct. I'm going to get the next one wrong on purpose. So I'm going to say 1 and 1. Notice it's going to tell me, oh, that was incorrect. -9 and 2 multiply to a -18 and give me a -7. I'm going to get one more correct real quick. So I have 2 darts to throw. I'm going to go ahead and miss the next one just so we can see what happens. Our code is going to draw the dartboard. Tells me I have 2 darts. I'm going to hit the clear button to toss my first dart, and congratulations, right off, I got 5 points. Toss my next dart, and I am pretty good at darts. That doesn't usually happen for me, but there is 10 points scored. So to get us started tonight, I'm going to quit that and go back to the home screen really quickly. If you are on a TI-84 plus CE with Python, all you have to do is hit the program button, and notice TI Basic is still there, but we're going to use Python. From there, notice you have menu options: run, edit, new, shell, and manage. The new button is right above your zoom button, so I will press the zoom. And then for ease of access, I'm probably not going to type all of darts right now. I'll just do the DA for darts. And then I'm going to go ahead and say OK. And now I'm in my program. Like I told you at the very beginning, we saw the big long line that said like from TI system import star, or there were some other library imports. I could type all of those today, but notice as an 84 user, all of your menu options are right above your Y = window, zoom, and trace option. So tonight, at any point in time, or later on when you look at the video or work through some of the activities that are found on the website, if you use the menus, so notice I just hit the functions menu, that's where I'm going to find how to write functions, or if I arrow over, there's my if statements. I can check to see if something is equal or equals, and I know that Adam's going to walk through that equals tonight. And so this is where I'm going to find a lot of my pre-built-in material. So let's say I notice for my modules, I need the math module. Right here, I just hit the enter button, by the way. Sorry, you couldn't see that. So if I just hit enter, it will go ahead and pop that in for me. The other tip I want to show you guys before I hand it over to Adam is this button right here. I found very useful. If you hit the Windows button, this right here will let me start typing on my keyboard. So if you're in the TI Smart View emulator like I am, I can start using my keyboard and just press the buttons. This is also a quick way to find any of the symbols that you're looking for. I'm going to quit out of this real quick. I'm going to hit the escape. Another quick tip, which is also in that documentation, but on an 84, if you hit second test, that's where you guys are going to find your options tonight when he does an equals. All right, so with that, I'm going to pass it over to Adam, and we're going to take a look at the Nspire version.
All right, if you passed it over,
I thought so.
because I don't see the share button's not lit up yet. Wait, now I'm the presenter. Yes, it was
Okay.
just slow arriving, that's all. Okay, and let me share my screen. All right, hopefully, and you're able to see my screen here. Now, much like Becky did, I wanted to show you what the completed version did on the Nspire. Now, this was put together slightly differently because when it was originally put together, the draw menu wasn't on the 84, but it was on the Nspire. Becky did a wonderful job with that. But anyhow, let's just run it. Now, this part should look exactly like the other one. So we'll just put some answers in here. All right, so anyhow, so negative, sorry, I can't think right now. I slipped something in, so it said correct, sorry. Okay, and let's miss something so I can miss stuff much faster than I do the other part. So we'll do -4, -3, oops, how about 3? And we'll miss another one, so we'll have 2 correct. Now see here, because the draw menu makes it much easier to put in all the filled in circles. We get this, and it was set up to toss with the T, and I'm not as good at throwing darts as Becky is. So, but this is the fun part that the students enjoy, but keeps them engaged as they go through and work the math problems. All right, now what we want to do is we want to go and build the first half of this. So we need to open a new program. And for those of you on the 84, you already have your new program open. For the Nspire, I just did it on the software, but you could have certainly just hit the on button and then new to get a new document, but whatever. And then once you do, come down to where it says Python, new, give it a title. And darts is as good as anything. All right. Now, you saw how this went through. It asked the question 4 times. So we want to start with, and I'm actually leaving something out, but we'll get back to that in a little bit. We want to start with a for loop so we can get those 4 questions. And so we'll come over here to menu and go to built-ins. For those of you on the 84, the built-ins, once you hit that FNS button, the functions button, most of the stuff except where it says module over on the far right side are your built-ins. And in this case, because we're trying to do a for loop, that's control. And this first one will work great. We need a variable, that's the index. It really doesn't matter what variable it is. I'm just going to put an I, and then we're going to put a size. Well, we had 4 questions, so we'll do 4. Then we'll come here. Now notice one thing. We have the 2 little diamonds on the left side. All those are spaces. Everything that's going to be repeated is going to need to be indented 2 spaces. All right. Now, we got the part that's going to repeat this. And what you need to think about as you're doing this is we're basically going to create a test, then we're going to ask the students the question, then we're going to grade the test. So first and maybe test is too strong, but whatever. But as we start by making the test, with me, what I do when I make a test is I start with the answer, then I build the question. Then obviously you put it on a piece of paper, but we'll get to that later. So we're going to start by getting the answer, sorry, and we're going to do M equals. Now on the Nspire, the little equal buttons over there, the quickest way on the 84 to get an equals is to hit the store button. But it's also in that second test that Becky talked about, because all those equal, double equal and stuff are there, but I really like the store button. And now we need to pick our answers, and we're going to let it pick it randomly. So we're going to go menu, random, and we're not going to be mean to our students. We're going integers. This is not magical, but -10 to 10 is a nice range for that. All right, now we want to repeat this. So I'm going to come down a line. As you come down a line, I get my 2 spaces again. And if I'm up here, one of the things you can do if you're on the Nspire is if you hold down the shift button and click over with the directional pad, it'll highlight. I really don't want to highlight that part. It'll highlight all that. Then you can do Control C to copy and Control V to paste. And then obviously all I need to change out is an N. On the 84, and I think Becky was going to put that in the chat. I can't see the chat at the moment, but there's a
It's
nice
under the
copy.
Zoom button. Yeah.
Got the nice copy and paste also. It's managed differently. All right, so now we have our two answers because what we're doing is factoring. And so we're going to have the quantity x plus m times the quantity x plus n. And now we need to put it together as a question. So we're going with a equal to 1 just because, well, to save time. But in the ax squared plus bx plus c. But b would be equal to m plus n. And c would be equal to m times n. Now, do be careful with Python to make sure you put the time symbol. And that's true even if you're doing 2x. You want to put 2 times x in between it, and especially with characters because it'll think you're trying to create a different variable. All right, so now we're starting to build the question we have. And so what we need to do now is print it out as a nice pretty thing that they can look at. So we're going to do menu, and this is a built-in. A lot of the things we're going to be using are the built-ins. And come down, IO stands for input output. And guess if you want to print it, it's called print. Now, the nice thing here is we can make it type. We can display a combination of text and the variable, and we're going to do that with x raised to the second power plus. Now, that little raised to is harder to type off the computer just real quickly. If you hit on the calculator, and this is either of the calculators, that you'll get the 2 multiplication symbols. And that's because that's raising something to a power in Python. And I guess if your students are playing with the Python, they might understand that. But if not, you can come in on the 84, that button, the A, capital A hashtag on the 84 has that symbol. And on the Nspire, if you do second and the catalog, it's just one of the ones in that group and we grab it. All right, now what I'm going to do is now I'm going to glue this to the B. Okay, concatenate. That word is tough for me. I don't know why, but now the problem with this is that plus symbol will only put things together that are both strings. And a string draws like it is right here in green, and that represents that that is just text. But B is a number, and so we need to turn that into a string or into text. And the way you do that is by changing its type. So we put menu, and sorry, I don't know why I'm just randomly going down, but anyhow, come over here to type. It's under built-ins and type, and then str is a string. And we'll just put old B in there, put plus, then X plus, and then we need our C. We'll string, I'm cheating and typing, I'm string C. Now there's going to be a problem when I run this. Well, there's going to be 2 problems actually. We'll fix the 2 problems. So we'll do Control R first. First problem is it doesn't know what my name random integer means. Now, by the way, I wanted to run this on purpose and so that you could see an error message. Really, you need to pay attention just to the bottom of the error message. I mean, it's on line 3 and random integer wasn't defined. Now, I just pulled that out of the menu list, but in Python, not all the commands are actually present when you start. So what you have to do is import what's called the module, in this case, the random module. And so if I go in random, right up there at the top, just like Becky brought in the math module with the 84, I want from random import. Now I got a lot of spaces, so I suppose I could get rid of some of those. Now if I run this and Control R on the Nspire, well, it ran just fine, but this is really ugly. I don't like the plus minus thing. And obviously there's plus minuses on some of the others. I just picked on that one. Now there's a couple ways you can do this. I'm going to approach this differently than's in the material. In the material, which is a brilliant way to do it, used if-then statements and just for different things. If B was positive, if B is negative, if C is positive, if C is negative, how you want it to display. But for speed, we're going to do it differently today. And I'm going to use a function to change basically the setup. So if you look here, the problem is we have a plus all the way down, but only the minuses show up because if a negative, you have to put like negative 17, you have to put a negative with it. So what we're going to do is we're going to get rid of all the pluses that are always there. But the problem is then things that are positive aren't going to have a thing in front of them. So in our function, we're going to go in and just put in positives, plus basically, in front of things that are 0 or bigger, so our non-negative numbers. How we're going to do that is using a function. Okay, if we go for functions, go to built-ins again, functions, and then we're going to put in a definition of the function. Now, I know just from experiences, people do this. Sometimes they just really have trouble wrapping their head around the fact that we call this a function. And it can work exactly like the function you know from math. But you might want to think of it also as a subroutine, because I think in this context, that may even be more what it's doing. But you need to call it something. I'm going to call it P and V. So I'm going to put a plus on the value. Again, you can see here when we get to the block part, it's indented 2 places, and everything that's indented 2 places is inside the function. All right, so what we're going to do is we need another if statement. Well, another if statement. We need our first if statement, but we need to go back to the control menu. So we do control, and I just need my little if statement here. One thing to notice when it comes to Python, Python does not use then, but the then is implied. All right, so what we want to do is we want to have something happen if V is greater than or equal to 0. Because I want to put a plus mark in front of a 0 also. Now that greater than or equal, if you're on the keyboard, you can type greater than or equal. But on the Nspire, you could do control equals. That's where it is there. And as Becky mentioned a little bit ago, on the 84, it's under the second math, the test menu. All right, so we got our if, and now you can see it's indented it 2 more. So this is inside the function, but also inside the if statement. And what I want to do is say V equals, so I'm going to assign V a plus. Oops, helps if I type right. A plus, then we're going to add that, and apparently I really can't type, to the string V. So I'm going to make V a string, and then I'll combine it with the plus. Now, as I come down here, the last thing I need to do is I need to return this back to the regular program, and we do that again in the same place, built-ins, function, and return is right there. And what I need to return is I want to return string V. Now all I need to do is I'm going to come down here and I'm going to change my display. Since this thing turns everything into a string, I no longer need the string command. All I need is a P, so it'll add a plus to it if it's positive. Make this one P, and then get rid of my pluses. Now if I run this, I mean, you may not like the plus 0, and you could get rid of that in the function too, but we're not going to go to that much trouble because You might not like the 1x either, but that's okay. I mean, you can add more program to get rid of those things, but we've made these look in a way that they don't look silly with the plus minus thing going on. All right. Now, just think about what we've kind of created at this point. Well, one more piece. I guess I need to tell them what I want them to do. So print, which you'd go back to menu, built-ins, input, output. And I'm going to do x plus m and x plus n, just so they kind of know what we're trying to do. Now, when this is your own program and you're writing it, you can add as much text in here as you want to help them see the problem. But now we have built the test, but we got to give the students a chance to answer the test. And so we got to let them input into the program. Now, the way you do that in Python is we're going to assign a variable to kind of collect the data. And it doesn't matter what you call it. I called it S and T. But we're going to let S equal. I'm going to come back in here in menu. Now, what I want it to equal, we're going to do input output again. We're going to do an input. Now, for anybody who really knows Python, something's not going to work great here, but that's okay. I'll get back and fix that in a moment.
Does anybody know what's going to happen while he types in his question? You want to, anybody throw that in the chat? What's going to happen when he runs that?
Well, the only problem, and you may not know, and this is not something you just necessarily pick up quickly on, but anything that comes inside the input is always going to come in and be considered as a string. So it's going to think it's text. But if we want to see if this is the right answer or not, we have to turn it back into a number. Even though it's coming in as a number, the program thinks it's text. And what we can do is just say S equals, come back to our menu, go back to built-ins and to type. You know, earlier we were turning everything into strings. Well, this time we want to turn a string into an integer. So we put int S. So I've asked them, so you input it in, and then I'm turning it into an integer. Now, one thing, you could have written this whole thing as one statement, have int input, and then enter, in this case, we're entering in. I'm adding the space after the N and the M just so it'll look better when it's printed. But you can compose your two functions. And actually, as you're doing this with a group of students, that might be something you can point out. All we're doing is composing functions and talk to them about what that means. And let's see, this is what's gotten me in trouble a couple times. You also need to close the second parenthesis. All right, now we've got the students' answers. Well, you would if you were actually running this. And we will run it just so anything I did stupid in there, we'll figure it out in a little bit. By the way, if I'm doing this in real life, I'm running this thing a lot more often than I am right now. Pretty much after everything I put in, I run it to see if it's working the right way. And trust me, it's not always running the right way. All right. Now, once they've answered the test, you got to see how they did on it. So we're going to come up here to menu. We did an if statement in our function earlier, and we're going to use it again, slightly different form of it this time. We're going to use the if else, because we're going to do, if they get it right, we want something to happen, and if they get it wrong, we want something else to happen. So how do we see if it's right? It's just, well, if S plus T, it better equal, now this is what Becky was talking about earlier with the two equals. One equal is assigning something. So like right up there above, I assigned S to be the input when the student enters, whatever they enter. Down here, I don't want to assign anything to S plus T. It has a value already. and you couldn't enter it anyhow as S plus T, but I want to see if that's equal to B. So the double equals basically returns a true. And then I want to and actually you could find that well, and you could type it, and it's in the OPS, I think, menu. I type it all the time. S times T, double equals again, equal to C. So the if statement is true, and this part runs if both of these are true. Otherwise, you get the else. Now, what do we want to happen? Well, as you saw when we did this, we want darts. So we're going to put in darts equals darts plus 1. Now, there's a trouble at this point because we don't know what darts was equal to originally. We'll fix that in just a sec. But all this is doing is taking whatever value darts has and adding 1 to it, and then reassigning darts with that new value. Now, let me just go up to the top of this thing. Sometime outside of our loop, we need to say darts. You don't start with any darts, so we're going to start with darts equal to 0. I could have run it. It would have given me a nice error, and it would have told me it was in line 23. So that would have been helpful. Now, one other thing. This is a perfectly good form that you could have used to do darts equals darts plus 1. But Python has a cute little shortcut, which I really like. You could write it instead as darts plus equals 1. It's exactly the same as the line above it, but a little bit shorter. So you don't need both of them. I just like the cute one, so we're going to go with that. But if you don't like this one, feel free to hang with darts equals darts plus 1. Now, here's where I break from the material once again. I just personally like drawing a little print that says correct. If you don't like correct, leave it out. Then I'm even pickier, and you could keep going to the menu and getting the correct and putting a little space there. There's nothing magical about it. It just looks good, I think. And then the last step, well, else, what if this thing doesn't work? Well, let's just say print and m equals, and then close that. Now, we used earlier when we were trying to combine a string with a variable, the plus string b is what we did there. But you also could have been just put a comma, and it'll do the same thing, except now I don't have to make it a string. The advantage of putting commas in between like this in the print statement is it's shorter. The disadvantage is it has a predetermined number of spaces it does for that comma. I think it's about 2. And you may not like the way it looks, so you can change it. And then just print. You don't need this other print statement, but again, I like a little space. So there you have it. Now, just so we can see if this actually works, we'll run it real quickly. And so whatever we get here, -4, 1. So we got 1 correct. See, -6 and 0. And we'll just miss the other ones unless I'm randomly lucky. Now, the problem is right now you can't really see if you got it right, but you can, as long as you're in the shell, any of the variables that are used in the program are available, and I can type darts, and you can see my darts is equal to 2, which means that part ran and did what I wanted it to do. And I didn't get any errors, which is nice. All right. So now it's Becky's turn again. So
before you pass it to me, can we talk about one common error real quick?
Sure.
Can you go back to your code?
Mm-hmm.
And then somewhere down towards the bottom, where you have darts plus equals 1,
Yes.
Will you forget the S on your darts? We know the variable is called darts, but quite often students will accidentally leave an S off or add the S on. And now, so they have darts above, and now they're using dart plus equals 1. So you have that variable that hasn't been declared yet. Will you hit run for a moment?
Absolutely. And I'll just miss them all. Well, no, I can't miss them all.
Oh, you got to get one right.
I
Yeah.
gotta get one right. Yeah. Okay. Which is really inconvenient, but okay.
Right, because you have to think real quick.
I know. Thinking is just, I'm gonna miss this one. Okay, I can't think. All right, this one I can get. 1, -1. And there it goes. Because it
So there it
says,
tells me, yep, so it says that dart is undefined, but then right above that, can you hover over where it says line 23? So on line 23, it tells us we don't know what dart is. So that S kind of there could be something that your students might accidentally add an S or remove an S, especially because you're talking plural darts.
and that's really nice that it says that bottom part is the part you look at, and it's wonderful because I can just go over here, go to line 23 and say, oh, I can't type, and you left it off. So would you like the ball now?
Sure.
Assuming I can do this. All right, make this participant a presenter, and it would be Becky. Yes. All right. You should be there.
All right. So the question was asked in the chat window earlier, how close does this look on the 84 to the Nspire? So I don't remember, did you import the math library on your version?
I didn't.
Okay, so this I had typed in. You didn't need the math library that's in there, but notice my definition is the exact same definition that Adam had from before. Even the color scheme is the same. So notice the red colors are used for operators such as an equal sign, a plus sign, or inequalities, where the blue is for reserved words like definitions and ifs and returns. And so I have the exact same code typed here that he had typed on his. I don't have the pretty spacing that he had because I didn't add those lines in. And I think I typed a correct in a little bit extra, but I have the exact same code that Adam had when he was doing his section. So we have our darts. Now to create the dart board. Well, let's go take a look real quick at the documentation. Documentation. So the dartboard that the students are going to create, and again, this is the teacher's notes and the students' notes are there as well to kind of walk you through, tells us that we want to make our entire screen have a width of 200 pixels and a height of 150 pixels. And then for our dartboard, it's going to be centered at 130/60. We'll have a radius of 20, a radius of 40, and a radius of 60. So there's going to be our setup. And then to make this happen, we're just going to plot points using the plot library. So it tells the students right here to draw a circle. We are going to use the radius times the cosine of an angle plus the center. So we're going to do a little parametric graphing here. But then notice off to the edge, if you're on the teacher documentation or the student documentation, both, they're going to tell the students, here's going to be the template and the code that they're going to fill in. All right, so with that in mind, I'm going to go over to my window and I'm going to do the first thing I said, which was, can we set up that window so that it's 200 across by 150? So I'm going to hit on my 84, my menu options are a little bit different. I'm going to hit the functions, or someone showed me the other, we'll go both ways. Functions, and then I'm going to go over to modules. And then from there, I'm going to go down to the plot library, which is number 5. And then I'm going to import the plot library with number 1. So I go the old school way. I call that old school because that's how I learned it a couple years ago, was to go through all of those menus. And then someone told me one day, they're like, hey, did you know if you just hit the menu option, it takes you straight, or the math option, it takes you straight to the modules? Well, yes, but that wasn't how I learned it. I learned it to go through those sequences. So you could either do the pathway we took or know to go to the shortcut. With Python, because I haven't used this library yet, I can import it right where it's at and it's going to run just fine. For those of you who've coded in Python before, I know a lot of time we put the libraries at the top, so the student document's going to have that at the top. I could have done that, but we're going to go ahead and leave it there. Now that I have that library imported, I'm going to go back into my menu options. I'm going to go back down to the plot library, and then I'm going to choose the option that lets me set up that window. We want the X values to go from 0 to 200. And then we want the Y values to go from 0 to 150. That way it matches the layout that we saw in the teacher document. And so from here, I'm just going to hit run and see what happens. Notice mine looks just like Adam's did when he did it. I can get to correct to begin with. Mine says I have an invalid answer. I don't know if you guys can see it. Well, you can see my screen. So looking on the screen right here, this guy's a -4 and this one's a negative. I must have hit the enter button before I hit the plus sign. So that will throw students for a loop, like it just threw me for a loop. I did not expect that to happen. Let's try that again, rerun that. So I need to multiply there. Let's try a 9 and a -7. So mine is correct. I go down, I get a 5 and a -4. I'm correct. Let's miss the last two. Notice nothing happens. So I didn't get an error. I set my window, but I haven't done anything yet graph-wise. So I'm going to go back down to my code. So to plot our points using the plot library takes anywhere from 40 to 60 points. If we go back and look at that teacher document, this one's going to have 60 points to make that outline. So to make that happen, I'm just going to use a loop to generate that circle. So you're going to go get your for statements using the functions. Over, you'll notice under control, I can say make this happen 60 times. So notice my menus look very similar to what Adam was doing on the Nspires. Templates are all there ready for me to fill in. First thing I'm going to do is change the color because we wanted that nice pink color around. So I'm going to go back to, let's use the shortcut button, hit the math, the plot library, and then under the draw, I have the option to change colors. To change colors, you're limited to really any color under the sun. You get to type in the RGB colors. Your red has to be between 0 and 255. To make the pretty magenta, I'm going to need 255 for the red. Then I'm going to need 0 for the green and 255 for the blue. And now I'm just going to plot that equation for a circle. So I'm going to go back into my modules. I'm going to go back over to my draw. And I'm going to tell it that I want to do a quick plot. And then you can choose how you want to fill them in. I think I just had 1 pixel for my circle. I might have had the circle operator there. So it might be a little bit smaller when we do just the dot there, but that's okay. So I'm going to make the radius. Well, let's go back and look at the teacher document. The radius for the magenta one should be 60, and it's going to be centered at an X value of 130. So on my plot, I'm going to say 60 times the cosine. Well, let's see. Cosine to me is a math option, but I know the math has got the libraries. Well, let's just hit that math button for a second. There's a math library, which I had already had imported in mine. For those of you following along, you would have to import the math library up at the top. Notice there's constants such as e and pi, and here's my trig features. So I'm going to say, what is the cosine of that? And then for my y values, I'm going to do the same radius, so 60 times, I hit the math button again. I go into the math window, I go to trig, I'm going to use the sine, and then I'm going to say, let's use that value. And then I forgot one thing. I gave it a radius, and we looked at the documentation. That is off-centered. I think I forgot to say the X value is at a +130. And the y value for the center is at a positive 60, I do believe. Okay, well, let's just run that out real quick and see what happens. I'm going to miss them all on purpose. Nothing happens. Well, great. Does that mean I need to get one right to begin with to make it show up? Let's check that out. 8, 1. So I got one right. I missed the next couple. Nothing happens. All right, so what do we think needs to happen? Any ideas? I lost my chat window. Do we have anybody in the chat window?
We have one answer of show plot.
Oh, there is a show plot option. Okay, so let's go try that out. So I told it to plot, didn't tell it to show the plot. All right, so in the documentation, the show plot is actually going to be at the very bottom of the screen. Let's see if order matters. So if I come in and I tell it to plot library, I tell it to show the plot, and then I rerun it. Of course, this will be things that happen with students as they're walking through the activity. Everything will look fine and dandy, and then one little line of code will mess them up, and that's okay. It's a great learning opportunity of, okay, what did we miss so far? Oh, can anybody see? I have a little teeny tiny faint line right here. Mine are small. That is really small. So maybe I shouldn't have chose the little dots as my options there, but that's okay. Notice all of this is still on the screen. And that's because there's one more important thing before I switch over to my plot that I need to do. I'm going to hit the clear button. Let's go back to the editor. So there's two things. One, the show plot is correct. We need that on there. But two, now I've just lost where I was at. We need to clear our screen of all of their practice. So if we hit the math button and we go back into the plot library, you're going to see that there is a clear screen option. So that's the first thing. That will wipe off all of their guesses that they made, hopefully all correct. And then for this one, I'm going to go change the symbol. If you don't have them memorized, there were 4 optional symbols that are in there. I'm just going to change it to the plus symbol because I know that's one of the 4 options. And now when I tell it to run, we get that correctly. What is that? A -9 and a 6. And a 1 and a 1 and a 1 and a 1. There we go. We have the start to our dart game. There's our dartboard. And we're off to the races. So the students are then, or us in that case, are going to continue on. And we need to get the other 3 darts. Well, I don't want to type all of that again. And so Adam showed earlier on the Nspire the shortcut of how to copy and paste. Here's the shortcut on the 84. This tools button is my favorite. You hit the zoom and notice copy line is option number 6. So I'm going to copy the color. Oops, I did that kind of fast. Sorry. I'm going to go down to the next line because I want to paste it below this one. And notice there's a paste line below option. And now I can change the color for the inside of my next one. The inside of my next circle was going to be, I think, this nice blue color. And so that was 0 by 255, 255. Since that is copied, I'm going to go ahead and paste it below one more time so that it's already ready to go for my next circle. And now I can come up to my pink circle. I can copy it. And I can paste it. And now all I have to do is change the radius. I don't 100% remember what that radius was, so why not look at the teacher document? The radius is 40. The next one is 20. So we'll come down, we'll make this 40. Same center. I'll make this one 40. And then if I arrow down one more time, I can paste a line below that one. And then I can make this one go to, I think I said 20. And now if we run it one more time, and let's just miss everybody. Oops, I forgot to change that color. I think it's supposed to be a yellow color. So I have my nice magenta, my bluish color, kind of like a teal. And then because I didn't change this one when I copied and pasted, it is in radian mode. You can change it to degree mode. That's a great question. Someone just asked that. I saw that flash on the screen. So if I hit enter and I hit edit, correct. Right now it is in radian mode. If you want it in degree mode, all you have to do is go right in front of my variable here. I can go back to my plot library. Not my plot library. What library are you thinking? Back. How about the math one to do math? Wait, not even the math one. It's the plot library. No. Help me out, Adam. Math. I'm going to my math library. I was right.
Right, math.
There we go. Math. And then inside the trig option, there is a degrees. And so now I can change this in here. We'll kind of see how that looks a little bit different. So we'll put that one in degrees. And if I highlight over this one, and I go back to my math library, and I go to degrees, we'll get a little bit different picture on the outside if I rerun that. And notice now they're not overlapping as much. And you can play around with the ranges that you wanted to make things show up the way they go. I think the documentation did 60 just because it was kind of a nice fill it in and make it kind of look full. Okay, so now that you have the dartboard, we're going to have to generate a random location to toss the dart. And then we're going to have to figure out if the dart is in the outer circle, the inner circle, or the middle circle. What math do you think students are going to have to do in this activity in order to find whether or not the dart earned any points, and if so, which point did it earn? You got it, Pythagorean theorem or distance formula. So I'm looking at the time here, and I think what I'm going to do is just walk you through the final product. And there's two different ways to do that. And I think to walk you through that, I'm going to actually just take you to the teacher activity. So if you're a teacher walking through doing this with your students, at the very end, I'm going to scroll very slowly-ish, not to make anybody sick, but at the very end, gives you the entire completed program. And so Adam and I, to save time tonight, cut out the fact that if you wanted to make it have an A value, the teacher documentation will let you have an A value in front. The actual documentation gives them a bonus feature as well. So if they get 2 in a row, they can get bonus points. So then if we scroll down to the bottom, after we've graded all of those, you'll notice here is our circle that we got to tonight. From there, what we have to cut short a little bit is the scoring feature. So the scoring feature, there's a little section that tells them they're going to hit the clear button if they're on an 84 to toss it. I think it's at the T button to toss on the Nspire documentation. And then for each dart that they've earned, they're going to get to hit the clear button for the 84. And then every other dart has some varying accuracy for the students. It will plot the dart, and then we're going to use the distance formula. Notice on Python, you have to do the ** in order to square it. And then based upon their distance, if it's within 20 units, they get 5 points. If it's within 40, they get 3. And if it's within 60, they end up with a point. And so that's the part we didn't get to tonight, but you all know how to get to the darts activity. And you download both the teacher document and the student document. So with that, I am going to pass the ball back to Mike.
Awesome. Thanks so much, Becky and Adam. So I was excited to see some of the questions that came up and definitely some of the chat between people tonight. Feel free to keep that conversation going on any of those major social media platforms, or if you have questions, that's another great place to get some of those questions asked. As promised, we are giving away to one lucky winner a TI graphing calculator of their choice, and tonight's lucky winner is Deborah McGee. So Deborah, congratulations. We're excited that you get to pick the graphing calculator of choice, and we'll be in touch over email in the next couple of days to get some of that information from you. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is going to be a link for the documents that were used tonight. And if these links aren't working for any reason, just hang tight. You'll automatically get a follow-up email. And in that follow-up email will be the links for the documents, the certificate, and the recording as well. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. If you have any questions, maybe you're looking to trying to figure out where you can get a TI-Nspire CE Python edition graphing calculator. Those kind of questions can definitely be directed to us at TI. Feel free to give us a call at 1-800-TI-CARES or drop us an email, ti-cares@ti.com. You can contact us for anything else as well. Feel free to reach out to us throughout the year. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback really guides us as we plan our future online events, and we really hope you share your thoughts in the post-webinar survey. Huge thanks to Becky and Adam for everything they shared tonight. It was really exciting to see so many people join us tonight and be excited about Python coding. Thanks so much, guys.
It was great coming. I'm hoping you guys picked up some good coding tips tonight.
It was really fun doing this. I hope you all enjoyed it.
And thanks again to everyone for joining us. We hope to see you back online next week. Have a great night, everyone.